Right. We have already discussed about lesson number 1, and so now actually we need to do the lesson number 2 because we skipped that. So let's move to that lesson, which is lesson number 2, the computer system and also the components of the computer system. Basically, the first lesson is usage of ICT, ICT in different areas, how ICT can be used, and also about the generations, computer generations. There are 4 generations. So what are the specialty of those 4 generations? We have already discussed, but if in case if you forgot, the first generation was focusing on vacuum tubes. That's why most of the computer has this acting, ENIAC, EDVAC, EDSAC, UNIVAC, because it's used vacuum tubes, right? Those were like basically use machine language. Very large computers was generating very high heat, and actually it was not a personal computer. You have to keep computer in a building. Loku ගොඩනැගිල්ලක තමයි computer එක තියාගත්තේ first generation. And again, so it was not possible to bring a computer to your home. ගෙදර computer එකක් ගේනවා කියලා එහෙම කරන්න බෑ, because it was really large and it is not cost portable and consumes a lot of electricity because it's a building like computer. So that is 1940 to 56. That was the first generation. The main technology was vacuum tubes. For the storage, input, output, and storage purpose, it used punched cards, right? Then come the second generation, 56 to 63. It is transistors, and the storage mechanisms were the tapes, floppy disks, etc. Tapes, floppy disks used for the storage purposes, and transistors were it was the technology for the processor. And there are some examples, not examples. Now you have some Honeywell, IBM, but on the UNIVAC, there was a second improvement of UNIVAC. It came to the second generation, which is transistor-based UNIVAC was also there. UNIVAC LARC, actually, that is called UNIVAC LARC computer. Anyway, so it uses high level, unlike the machine language and the first generation assembly language, machine language, it uses high level programming languages, high level. So human readable languages, but these are machine readable languages. So these are more human friendly languages. That is relatively smaller and faster, but still not portable. It was not possible to bring a computer because it is also large. Even though it's smaller than the first generation, it was also large. So what is the third generation? Yes. What is the technology of third generation? What was the technology in third generation? Yes, first generation vacuum tubes, the second generation transistors. The third generation, any idea? Yes?
Integrated circuits.
Yes, integrated circuits. It is integrated circuits. IC. Integrated circuits. A lot of transistors together created IC. That is called integrated circuit. That is the third generation. And then come to the fourth generation and introducing the operating systems. Operating systems were introduced in this generation. First 2 generations, there were no OS. And here you have OS and also high-level languages were used. And personal computers actually started in this time, but actually it was wider use in the fourth generation. The third generation also, it's not that much personal, but still possible to buy a machine to office use maybe, right? So it was low power consumption, faster than the previous 2 generations, smaller in size. Fourth generation is it's 75 to 89 period. So very large scale integrations and large scale. So same thing, microprocessors basically. Microprocessors or large scale and very large scale integrations. So use ICs ගොඩාක් එකතු කරලා හදන ඒවා තමයි fourth generation එක use කරන්නේ. So this is just, I'm just recovering, right? I want to you to remember this stuff, but when the examinations are closer, you can go through these things and remember easily. The first generation, fourth generation, the technology was VLSI, LSI. Very large scale integration, and large scale integration was the first okay. Then very large scale and large scale integrations. And actually floppy disk, optical disks, Pen drives came in this generation. The memory cards all came in the 4th and 5th generations. And GUI, graphical user interface, was there, and Apple, IBM, personal computers became portable, means you can bring a computer home. It's a portable one. And it uses very small amount of power. You can run a computer with a battery. So laptops introduced in the 4th generation. The 5th generation, which is current generation, so it is ultra large scale integrations, very small smartphones, portable computers, and high usable or high user friendly interfaces. Artificial intelligence was introduced in the 5th generation. Notebooks, then these workstations, notebooks, palm tops, PDAs, then smartphones. So those are widely used in the last generation, which was the 5th. So that is just what we learned in the last lesson, not last lesson, actually we learned that in the beginning. Now it's time to study more about the fundamentals of the computer system. In this chapter, we are going to learn about hardware and networking. Basically, that is the chapter. So this is also a theory chapter, but we will make it as much as interactive, even though this is theory. We would like to introduce more things into the middle, but today we will be discussing theory part. So basically, we need to learn what is computer here, and also the features which are unique to the computers. We need to learn that, and also the classification of computers according to the size and according to the technology, analog digital computers. And also today we are going to learn about the basic functional model or von Neumann or block diagram of the computer. So that we will be learning this lesson. Okay, Bhute, please go and write down a heading. So that is computer system. Computer system. Okay, data within bracket, basic facts about something, someone, or some concept. Data is acquired as input. Data is acquired as an input and processed mathematically and logically to produce meaningful information as the output. Meaningful information as the output. Data is acquired as an input, processed mathematically and logically to produce meaningful information. Meaningful information as the output using a set of interrelated components. Please write down this. Okay, what is this system basically? System means system. Yes, let's write down. System is, so you need to know that system is a set of, so what I said here is system. Set of interrelated components connected together to achieve a common goal. We call that, to achieve a common goal, we call that a system. The main functionality of the computer system is data processing. the main functionality of the computer system is data processing. It has 3 subsystems. The first one is hardware. So hardware has like input devices, output devices, processing devices. Please write down, I'll explain. Communication devices or memory, storage, communication devices, that is called hardware. Then the second one is software. There are 3 system, application software, and firmware. The third one is liveware. Developers, engineers, users, sellers, quality checkers, manufacturers, all kind of people can be categorized as this. So please write down quickly. Right? Okay, so then the computer system has 3 main subsystems. Hardware means physical or tangible components. If you don't know, these are very basics, but sometimes you might not know these physical or like you can say tangible components. So software means intangible instructions, a set of instructions or instructions. So liveware, you know, the living beings, right? The living people basically for using developing, engineering the computer system. And this is how the computer system is composed. So let's see how we can categorize the computer. So what are the categories, right? Categorization, please write down. Categorization, and the first category is we have to divide based on the size and performance. So what is the highest performing computer type? So what is the highest performing computer category? Yes? Any idea? What is the highest? Yes?
Supercomputers.
Supercomputers, yes. Supercomputers. So supercomputers are really faster and it can provide supercomputers. So actually, so you have very high one, that is quantum computers, but still the quantum computers is not indicated in your syllabus. Quantum computers will be even more faster than the supercomputers. But still, we are not discussing about quantum computers in your syllabus. But actually, remember that the quantum computers are more faster, even more faster than the supercomputers. Okay. Supercomputers, then supercomputers, you can say, just give me 1 second. Right, supercomputers, please write down. It can provide simultaneous ekavara. Simultaneous can ekavara. It can provide simultaneous service to several hundred thousands of clients as a server. So these are called server computers basically because it can provide a service. Large companies like Google, NASA are using using these servers. Several 100,000 of clients, right? So very large amount. Then comes the mainframe. There are two categories. So one is old mainframes. Ancient, first and second generation building size computers. So those are also called supercomputers, sorry, mainframe computers. So large building size computers. ඒවටත් කියනවා mainframe කියලා. ඉස්සර තිබ්බ පරණ computers වලටත් mainframe කියලා කියනවා. හැබැයි ඒ computers නෙවෙයි මම මෙතන mainframe කියලා අදහස් කරන්නේ. New mainframes. New mainframes basically it can provide several thousand of users. Not lakh, but several thousands of clients as a server. A lot of companies are using these as servers. I'll show you images, right? I'll show you images of these. There is the second category. Third category, the third category is mini computers. Okay, first of all, please write down the first two. These mainframes and supercomputers, basically this is how those mainframes and supercomputers are stored. Supercomputers is a single word. So you can see this is a supercomputer. We call a supercomputer farm. It's not a single supercomputer, a set of supercomputers. Here this is also a supercomputer farm. And this is also a supercomputer farm. These supercomputers are stored. So this is a single supercomputer, but these supercomputers are stored in a network environment. Those are connected using network and stored as a farm. Why these are stored as a farm? Because it is required to provide some facilities to these supercomputers. And it is required to provide some facilities to these supercomputers, like these supercomputers need high power. It consumes a lot of power. So separate power plants are there to provide power to the supercomputer. You can see power plant. So some organization, they are using here. So this is a cooling plant. So understand the level of the heat generation. This is cooling plant, and several. So this is, you can see. So this is area where the supercomputers are stored, and special facilities need to be provided. Special cooling facilities, special power backup facilities, and special security need to be provided. So it is a wastage if you just isolate one supercomputer, unless if you extremely need that. So isolating and providing these facilities is so a little hard. It's expensive. That's why all the supercomputers are placed in a single single cluster. So this is called a supercomputer farm, and they provided these facilities. And mainframes, you cannot see much difference there. So this is mainframe, right? Mainframe also looks like supercomputers. Mainframe supercomputers or mainframe computers. Here, this is the mainframe computers. You can see this also looks like supercomputers, right? Mainframes are also, like mainframes are also, it also looks like a supercomputer, but little, so much smaller, not that much, but little, like sometimes it's similar or smaller in the scale. It can provide thousands, but අරවා 100,000s, ලක්ෂ ගානකට පුළුවන්. මෙයාලට ලක්ෂ ගානකට බෑ, දහස් ගානකට පුළුවන්. ලක්ෂයකට විතර ඒත් පුළුවන්. දහස් ගානකට පුළුවන්. සර්විස් එක දෙන්න එකපාර. So remember that no one is connecting these supercomputers, and so මේ supercomputers එම connect කරද්දී. So how the connection happens, let me show. You can see this one, right? This is the connection diagram. You can see the mainframe computer plant is connected to the switch, and this switch to this switch, all the terminals are connected. Then අපි Google access කරන්නේ. Think about how we access Google. Google is a supercomputer. We are accessing a supercomputer. We connect to the internet, and through the internet we are accessing the Google servers. So our computers are terminals basically. Our computer will act as a terminal. අපි නිකන් අන්තිම edge එකේ ඉන්නේ. අපි network or internet හරහා තමයි මේ supercomputer එක access කරන්නේ. So actually, when you are visiting Google site, you are visiting a supercomputer. But simultaneously, another like several 100,000, several millions are visiting Google at the same time. Right? We are also accessing, they are also accessing. So it should provide service to all of these computers. So it needs to provide the service. So this is what happened, right? In the supercomputer environment, this is what happened. So all are connected using the network switches or network. Mini computers. Mini computers can provide simultaneous service to several hundreds of users, right? To several hundreds. It's not thousands, it's hundreds. Smaller in the, is also smaller in the scale. Several hundreds of clients, right? So basically, so smaller than supercomputers, smaller than the supercomputers, and mainframes. Sometimes known as workstations. Workstation servers. Some are used in high-end can high, powerful, high-end multiplayer games. Sometimes known as, so some are used in high-end multiplayer games, right? So those are, those are the mini computers. Mini computers actually, so even though it's a mini computer, you can see it's not mini. So mini computer is still larger. It's a large cabinet. You can see large cabinet like computer. So, but it can facilitate. So maybe the small scale companies use this as a server, right? Medium and small scale companies are using these as servers. Servers means the service providing computers. That's it. Okay. Right. Based on the size and performance, the first one supercomputers, the second one mainframe, the third one mini computers, and finally you have the microcomputers. Oh, sorry. Microcomputers. Microcomputers. Yes. Yes. Yes, Pate. Can hear you. Can. Yes, you can ask the question.
I can't hear you properly, sir.
Still? Others? Lashain, Senoli?
Can, yes, sir.
Can, right? Okay. I think Kusal, you have to check your connection. Right? Please check your connection whether you are.
Sir, I think because of this power cut, sir.
Yes, sometimes due to power cut, there is a signal loss, right? In case if you cannot hear me properly, so I recommend you to watch the video again after the lesson. You can watch the video. So I recommend that. Okay, microcomputers. These are the computers that we use in our day-to-day life.
Okay, sir.
So these are the computers that we use in our day-to-day life. So you can say laptops, tablets, desktops, smartphones are examples. So those are some examples to these microcomputers. You know the features, so these are not used as servers, these are used as client computers. These are client computers. Okay. So next is we have to discuss about the technology. Before that, please write down this. Right, the next point is we need to discuss about the, so now we discuss about the categorization based on the size and performance. The second categorization happened based on the technology used. Okay, based on the technology used, we can categorize this into two categories. So one is actually three categories. The first category is analog computers, and the second category is digital computers, and the third category is mix of that is hybrid computers. So analog computers, basically analog computers, analog computers use analog data and analog signals. What is analog data? Analog data means a data or data item, or if a data item get any value between a given range, we call analog data. Example, you can say height can be any value between any given range. Then analog signals, a signal means a data at transmit, right? ගමන් කරන data එකක් තමයි signal එකක්. A signal which can get any value between a given range. Any value between a given range. Example, you can say voice. Voice is data it at transmit. ගමන් කරන දත්තයක් voice කියලා කියන්නේ. So if it can have any value 20 24 20000 අතර සීමාව තමයි අපිට ඇහෙන්නේ. We can hear the human hearable range is 20 to 20,000 hertz. So it can take any value between that given range. So then the digital computers, similar to this, it uses digital data and digital signals. Digital data and digital signals. It can take given value, not any value, it can take given value between a given range. And so that is digital. Here, digital signal, a signal which can get given value within a given range. So example for digital data, you can say grade. Your grade can be grade 1, 2, 3, but not 1.5, 1 and 1.25. Not like that. It can be 1, 2, 3, only given values. And then so this can be a network signal, a digital network signal in computer network. Normally in the nature, we cannot see the digital signals much. Digital data are there, but digital signals we cannot see much. Hybrid computers, so they are using both analog and digital data with signals. That is hybrid. I couldn't write examples for these computers. Actually, analog computers in scientific projects. Basically, scientific projects, you have analog computers. The digital computers, personal computer. Computers used in researches. You can call them, so these are examples for hybrid computers. Analog, digital, hybrid. So please write down that. I'll give a diagram after this. After you write down, please tell me whether you have finished or not, right? So then I'll move to that. In the left-hand side, you can see analog signal and two kind of analog signals. Both are analog. You can see it's getting like it can be any value between given range. This is the maximum and this is the minimum. In between this maximum and minimum, it can range, right? It can take any value like that. It can take any value between a given range. That is analog. But see the digital signal, only two values, this value and this value. This value and this value, only two values here. And here in this one, there are multiple values, but still these values are fixed. You can see it's like a ladder, only fixed values. It's not any value, only given values. Here also, this is another analog signal and this is a digital signal. You can see it's only taking the digital value. Here it has two values. But anyway, it is basically the fixed values. So you just draw the left hand side, you have analog. The right hand side, you have digital. So please draw this as well quickly. And let me know once you are done. Right. What we have learned today is basically, let's go to the book. We learn how to categorize the computer. Basically, I couldn't discuss about this. So there are some features which are like with the computer, there are some special features. So the speed of the computer, we need to discuss because like speed of the computer is amazing. So it can process millions of instructions at a time, at a given second. Instructions over this million execute. So think about the ability. Currently, the computer can compute this much of instructions. It can process this much of instructions and produce the output. That is super fast than human. And the accuracy. So let's say you have given incorrect password, only one letter incorrect, but still the password is incorrect. So let's say your password has 30 characters. In this 30 character password, one letter is incorrect. Still the password is incorrect. So it is perfectly checking the accuracy, and it respects the accuracy and provides accurate information. Unless if there is a program error or software error or any kind of like bug or error, so it produces accurate information and timely information. So let's say you are typing a URL, you are going to a link and one letter incorrect, then the link is incorrect. If you are sending email, one letter is wrong, so email is not sent. So that is the nature. The efficiency. The efficiency, computer is never getting tired, unlike us, doesn't need OT, overtime, no overtime, nothing, but it can work always in the same consistent manner with high efficiency. Efficiency means the amount of work it does within a given time. The amount of work it does within a given time. Let's say ATM machine, in the night, in the midnight, in the morning, in the dawn, in the noon, anytime it works same way, similar way. So efficient and consistent too. So consistency is not measured here, but efficiency and consistency. Let's say you are behaving in different time, you are behaving different way. So let's say somebody call you and ask an equation in the midnight, 12 p.m., 12 a.m., the midnight. So your answer would be like, oh, I'm sleeping, don't bother me. So that will be your answer maybe. If you're sleeping, if not, you might give the answer. But sometimes you can scold them. But the computer, it doesn't matter. It's consistent. Anytime, it will provide the same answer. For any person, maybe if your brother come and ask you, so what is 1 plus 1? Or what is 2 plus 3? You give the answer. Your sister comes and asks the same question. Maybe you can give. So your mother and some, let's say your elder brother, everybody come in and ask the same question from you. You might not give the same question the next time. You might ask, so why you all asking the same question from me? So that is you. You're not consistent. But the computer, if it If it is asked, what is 3 plus 2? Even 100 times if it is asked that question, it will give the same answer, same consistent answer. Consistency is also there. So additional feature, please write down efficiency and one more, consistency. Niyata bhava, consistency is also there. Versatility means it can do multiple works. While watching a video, you can download something. So likewise, it can perform multiple works. And storing and retrieving facility, it has high storage. You can save and retrieve. So you can even save millions of books. You can save thousands of movies in your computer. So it has high storage capacity, as well as it allows you to retrieve those anytime. So those are the features of the computers that we need to know. Speed, accuracy, efficiency, consistency, versatility, and storing and retrieving facilities. Then we learn about the classification. We learned analog computers and digital computers and hybrid computers are according to the technology, according to the size, supercomputers, mainframes, mini computers like workstations, especially used in gaming, small servers. Then the personal computers, microcomputers. Analog, digital, and hybrid computers we learned with the technology. Then the functionality of the computer system that we have already discussed. The functionality of the computer system we have already discussed. Due to this signal issues, you might get some lagging and all. So, it's not really good these days, but anyway, try to manage it. And if it is not clear, what you can do is you can listen to the recording, would be clear. Okay, if I ask a question, what is 2 plus 3? Your answer will be 5. 2 plus 3 is 5. So then if I ask, okay, what is 2 plus 3 divided by 2, multiply by 8, subtract 3 and multiply again by 13, divide by 7 and add 2, what is the answer? Now you cannot tell the answer, but same mathematics. Why? Because my question is lengthier. So now everything is there in those two questions. 2 plus 3 is 5. 2 will go to the memory. 3 will go to the memory. 2 plus 3 is 5. 5 will also, 2 plus 3 will be going to the registers, and the ALU does the calculation. Control unit is like a policeman in a junction. It's a traffic police in the junction. It can signal. The CU can signal, go right, go left, now up, now stop, now move. Likewise, the traffic police is signaling. Traffic police signals, then you drive karanne. ඒ වගේ තමයි control unit signals දෙනවා. Now take the input, take the output, go to and storage it. Likewise, signals දෙනවා. මේක කරන්න කියලා signals දෙනවා. So according to that, ALU is doing the calculations and registers are used to keep things in the process වෙනකොටත් තියාගන්න එපා memory එකේ. So that memory is the register. Okay, 2 plus 3, first go to the main memory, right? 2 මතකයට යන්නේ. 3 මතකයට යන්නේ. Then to the processor. After calculation, coming back to the memory 5. Now if I ask the answer, it is 5. Now the output. The large one that I say, it will first go to the memory, but memory is not enough. දිග වැඩිනේ. Then it will go to the storage and ඔගොල්ලෝ කරන්නේත් එහෙමනේ. දිග වැඩි ගානක් දුන්නොත් save කරගන්නවා. නැත්තම් ලියා ගන්නවා පොතේ. මෙයාලත් එහෙම තමයි. If this is longer, it will use the secondary storage to write down. For large films will be there in the secondary storage, large movies, large software, it will keep that in the secondary storage. It can save and open. Saving means memory to secondary. Opening means secondary to memory. So if it is large, then from the secondary you take page by page, one by one and do the calculations and then go. So this is how the computer behaves. That is function of the computer system. Let's learn about this next day more carefully. For today, I'm going to stop from here. Next day, we'll discuss more about the functionality of the computer and also learn about different devices. So good night. See you all next week.